given an expression. Say for instance something like sine of 180 degrees plus theta or x or whatever the case might be, and you need to reduce that to a single trigonometric function. You can always make use of the three-step method. Step 1 says first find out whether the expression is positive or negative using the cast diagram. Now the cast diagram works like this: C, A, S, T, and it indicates the functions and their signs in the different quadrants. So C stands for cos, A stands for all, S stands for sine, and T stands for tan. So those will be the respective coordinates where either one of those trigonometric functions will be positive. So when we look at sine of 180 plus, it means that we are in that quadrant, the third quadrant, and we can see that sine is no longer positive there. So according to the step 1, we can then just put a minus in front of that expression already. That's step 1. Step 2 says, look at the 180 degrees. Is that a horizontal or a vertical axis? Which will be that part of the expression. If it is a horizontal axis, as it is in this case, because 180 degrees lies on the horizontal axis, then sine would stay sine. So we can just write it in. If it was a vertical axis, so either we used the 90 degrees or the 270, sine would change into its co-function, which is then cos. Sine and cos are co-functions of each other. And just to complete the whole list for you of all the trigonometric functions, we've got sine, cos, tan. Those are the three familiar ones. Then we've got cot, sec, and cosec. All 6 trigonometric ratios, and those groups are co-functions of each other. And you can actually see it. Co-tan is what the abbreviation cot stands for. Co-sine is what the abbreviation cos stands for. And you can see there, sec and cosec. Those are the co-functions of each other. But that only applies when you are working with a vertical axis inside your brackets there. Then you would actually change the function in front into its co-function. And then step 3 says fall away, which is that part, 180 plus, or whatever is standing there, would then simply fall away, and your final answer for this expression would then be minus sine theta. So the whole sine of 180 plus theta has now been reduced to just minus sine theta, which is a lot easier to work with in an expression where you need to simplify. So looking at some examples then, let's take a look at a couple of examples that we've got there. The first one we've already done, sine of 180 plus x. So we know that will then become minus sine of x. The cos of 270 minus theta. We now need to work this one right from the beginning. 270 minus means we are ending in the third quadrant as well. That's according to step 1. And since we are working with cos, but it is in the third quadrant where tan is positive, we will also put a minus already. Then we are working with the 270 degrees, which is a vertical axis. So cos will change to sine. And then step 3 says that part falls away. So all that remains then is theta. So that whole expression has been reduced to minus sine theta. When we are working with specific degree values, such as 315, you can actually write this expression as tan, for instance, of 360 degrees minus 45 degrees. If you don't want to work with the vertical axis, stick with the 360 degrees. As you can see there, that's also a horizontal axis. But then we've got this expression 360 minus, so now we apply the 3-step rule. 360 minus is in the fourth quadrant. Now in that quadrant cos is positive, but tan is negative. Then we are working with a horizontal axis, so tan stays tan, and step 3 says that part falls away, so all that remains then is the 45 degrees. And there you've got an expression, minus tan 45 degrees, that you can actually simplify without a calculator using your special angles. And then just looking at the very last one, sine of 225 we can write as sine of 180 degrees plus 45 degrees. Below the line, we've got cos of 135, so we can write that as cos of 180 degrees minus 45 degrees. And then we apply the three-step rule for every one of those expressions individually. Very important point that you need to take consideration of. When you are working with combined expressions, such as that one, or even bigger, take them one by one. So we start with the sine 180 plus 45. First of all, 180 plus 45 is in the third quadrant, so it will be minus. Then 180 degrees is a horizontal axis, so sine will stay sine, and then that part falls away according to step 3, and it just becomes minus sine of 45 degrees. Below the line, we've got cos 180 minus, which means it's in the second quadrant. Cos is also negative there. That is a horizontal axis, so cos will remain cos. That part falls away and it just becomes cos 45 degrees. But now we can actually cancel out the minuses. There's no problem in that. But then we would still end up with sine 45 over cos 45. And you need to then simplify that a little bit further, using either an identity, which you learn about later, or alternatively using the special angles. But if you observe that you could have used a vertical axis there. So let's rewrite this whole expression saying it's sine of 180 degrees plus 45. Remember, ultimately we need to get to 225 from that operation there. So we've got 180 plus 45 is 225. Then below the line, instead of using 180 minus 45, let's say that's cos of 90 plus 45 degrees. It would still give us 135 degrees. There's no problem with that. Above the line, we know that that whole thing would simplify to minus sine 45 degrees. But below the line, what we have now is again a minus, because it is cos 90 plus, it's in the second quadrant. But then because of the vertical axis, the cos would change to sine. It will change to its cofunction. And when that part falls away, it becomes sine of 45 degrees. And now the whole thing will cancel out and provide an answer of just simply 1. And if you work this whole thing out with the special angles, you'll also find the answer ultimately is 1. If you start cancelling all the fractions that end up as a result of that, and as a result of that in the special angles, you'd end up with an answer of 1.